The problem that you all have is this. As you know, we go right up to the bell, and that's good for you. But bad for you, because when you all come in on the days where I have, Algebra 2 1, Algebra 2 Section 1 in front of us, which is actually only on days like today, if you can give me a minute or two before you take your assessment, because the other group is still leaving as you're coming in, but due to this stupid schedule, you're a day behind them. So if you see assessment, you're going, we didn't do this the other day, make sure you check this why. The other thing is your note packets are currently over there. Some of you may have picked them up, some of you didn't. If you didn't, that's fine. Just go grab a note packet now, please, and a homework packet. And when you get back to your desk, are you able to log into your calculators? Does it work? Yeah, let me check. Yes. So go in and log into your calculator when you get back. I'm sorry for making you get up a second time. Your password is 1234. Your name when you go through and do it is the first letter of your first name followed by your last. So Bob Smith is B. Smith, 1234. Go through, make sure that you logged in. Now, the other thing is, the homework packet, I get it. So writing on it is very small. They want us to use less paper, and I use probably the most paper in the entire district. Now, did we ask you before? Well, let's ask. Who would like a Great Big Giant Algebra textbook to carry around? Who would like me to spend 2 hours of my precious weekend time not going to movie premieres or the best restaurants in town, but rather sitting at home and copying from a textbook and making a smaller note packet for you? Which of those would you rather have? Would you rather have me give up my weekend so I can go through? So we have less? Thank you. See? Get in front of that computer, and I'm not going to bother. So, the compromise is, instead of waiting at the copier for all of these to go through and finish, what you need to do, see over here, your homework, the schedule is on the right. And by the way, this is in Google Classroom. If you want a Great Big Giant copy, you can zoom in as big as you like. These are on here. By the way, quickly go to day 2 and cross out worksheet 2.2-1. That's not part of the assignment. All of your homework is in there. Now, you've got to remember that these are just slides that I put together. So, your homework, this is day 1. So your homework is there, and if you look over, it's done sequentially. So when I do this, the first one says what's going to do is page 67 and 68, number 10, 27, blah, blah, blah. If you look over on the right-hand side, you're going to see all of those. They go in order, so once you get 10 done, you might want to put a check next to it. Now, you don't do this homework in the packet, you do it on separate paper, please. And one thing, it's a lot easier personally if you just tell me. I'm more capable at dealing with it if you just tell me to my face that you hate everything about me than handing me this here. I'm able to personally deal with it a lot better than I am with these like tentacles that somehow are on the side of the paper. If you need loose leaf paper, because I know I'm quirky, but I'll make it up to you. If you need loose leaf paper, over here, how many is this piece of paper? Maybe 100 or 200 are here. And then if you need more, of course, you could go over to this section, which is 400 pieces of loose leaf paper, or maybe one of these 10 packets here that I have of 120 sheets apiece. Okay? Paper, I don't care. Another thing, some of you give me papers with some sort of biological stain, I guess, staining on them. I don't know what's actually happening to the paper. It sort of makes me feel bad for it when I get it. And I see like there's this like random like green discoloration, some evaporated liquid or whatever is happening to it. This paper looks like it hasn't had a good home life. Like maybe if it was a dog, we would call Animal Protective Services to get it taken away. Be delicate with your papers. Because when I go through, and again, this is me being selfish, when I go through and I've got 30 pieces of paper, right, and I need to go through and grade your homework. So this is from the other class. This, I can deal with. Nice. And there's a stapler on my desk. I will caution you, it's electric and quite powerful. It might even be so strong that it's illegal in there. Now, here's, like this, I can deal with. Look at this, that's a piece of blue sleeve paper. Some people really went all out and did, graph paper, the whole deal. I don't, you can do your graphs by hand. But this, I struggle, and I'm like, oh. Now, this person, they tried ripping, and were mostly successful, but we'll let it fall. This even, you guys are enriched, not me. Sometimes, especially at college, I get a paper from someone. I had a person handed me a piece of paper once that smelled. Think about that for a second. You know what had to happen to this piece of paper for it to absorb odor? Like clothing, you can understand, because people maybe sweat when they wear clothes. What happens to this paper? It smelled like a swamp. Like literally, I was at my desk, and I'm going over, and like there's people with doctorates, and you could be asking them any question in the world about math. Can you show me this? What is this? How can I better teach this? And I'm sitting there going, oh my God, Bob, can you smell this? Is this? You ever had paper that smelled before? Nice thing. Love it. Embrace the home. Okay. Now, our units for the next note packets are here, and I will caution you with this. We are topic because we paired up with some people from Pittsburgh and Fayetteville, Maryland, which is outside of Syracuse, to go through and get a collective pool of really good resources. That's why we don't use a textbook most times. We use this material because obviously we're very, very intelligent and we're smarter than books. So we put together this, design this course. The problem is some of the teachers have periods and some of us have this 55-minute block. So there's going to be days where we may get 2 topics done or 2 days worth of material done. There'll be days when we only get 1 done. There'll be days when we get 1.5 done. It happens. Now, we're going to start off with, and hopefully this is an easy intro. And by the way, the other thing is, that last unit on factoring that we went through and did, notice I didn't give you a big test at the end. I just gave you some group work to do. Some of you were very successful at it, and some of you might have struggled, and that's fine. We're going to do everything it takes to get you to be successful. Again, you're going to do so well on this exam that they're going to fire the Thomas teachers. That's the goal. And I go through and look, and this is another thing, I don't judge based on what you got previously. Because I sat there and looked the other day, and I was talking, and I noticed that there's a feature on the computer that lets us graph stuff out, or pull the giant reports with you. I said, gosh, I wonder how they did it. So I pulled all of the reports. Within the 4 sections of Algebra 2, within the 4 sections of Algebra 2, honors, we have geometry grades on the Regents exam, from a 51 up to a 99. So is that a broad spectrum? Yeah. The other thing is, and we'll say it to you nicely, your grade is a reflection of what you know. I can assure you, your 4 quarters in here will be lower than your Regents score. Your Regents score should be phenomenal. We're talking 90s and above for all of them, every single one of them. If you are all in, I am all in. And we, as a group, are all in all the time. We don't take breaks. But the trade-off for that is you have to understand an 85 and 87 is respectable. That means out of about 100 questions, you would get 87 of them completely correct. That's a lot. I know that sometimes before, maybe the people that you've had have been a little bit easy with you and treat you like little babies that don't mean it. Let's move. If you bring in brownies for everybody, and you go through and you get cupcakes and stickers for everybody, you get 100. I told you before, I love when they get up at the meetings and they go, oh, Bob is phenomenal in art. He is just terrific he's so terrific, his average is 147%. If you understand math, you should understand you can't get anything above 100%. You know how difficult it is to get 100%? At least you haven't missed anything all year. I've had students in my class who went to Harvard. They didn't have hundreds during the year. The kid that I had that went to MIT didn't get hundreds during the year. They had mid-90s. And it's fine. We want you to, and it's not to have a false sense of self either. Now, and I'm telling you now, I was trash talking Miss LaRocco for time. We should say, I hope you guys are buckled up over there. She goes, what? Wow. The kids I have are so smart, they don't even understand. They're going to mop the floor with your idiots. Because you don't even know our Algebra 2 kids. I go, I don't need to know. My kids are so smart, it's disgusting. It's disgusting. Then she went, and then I got a nasty text message from the person who actually teaches it over time. But whatever. Wrong. Now, a linear function is a function whose graph is a straight line. And by the way, hands up please if you notice what changed in here from yesterday to today. Hands up please if you notice the big change that happened from the last time we met until today. No one saw the change when you came in from last class to today? Seriously, one person? What? What's our shape going to be for this unit? You know how long those took to make? That's supposed to look like magic. That was over an hour yesterday. 3 of us spent in here going through and making that look like a line. And don't you dare be the one who says, well, technically some of those points aren't really linear. Somebody in the other class said that. That's a line. That's what we need. Now, does that line going from left to right, does it have a positive or negative slope? There you go. We're going to change the graph up as we change units. That's what our unit is. We're working with lines. Now, mathematically, this means that the function has either 1 or 2 variables with no exponents that are raised to a power other than 1. So if we're going to talk about this, we'll give out an example of a linear function. So some functions that are linear are going to be y is equal to 2x, or y minus 5 equals 3x, or y equals x. Something that's not linear is going to be y is equal to 2 to the x power, or y equals x squared, or y squared equals x. Both of these are going to be parabolas. If it's a y squared parabola, it opens to the left or to the right instead of up or down. Those are nonlinear functions. Questions on that? All right, bounce over to the next page. These are linear functions here. Notice the x and the y are all to the first power. The ones on the right-hand side are not. Over here, if you've got an x squared term, this is going to be a quadratic expression. This right here, e to the x, is exponential. Now, notice from here to here, is the change in y over change in x going to remain constant? Well, according to this table, each time here I'm going up by 2. That's really not that significant. But the change in y over change in x ratio is. Each time I go up, I'm adding 2 for every, adding 3 to the output for every 2 I move up on the input. So that means that that table shows a linear relationship. How about over here? Well, as I go up by 1, my change is by 1. This goes up by 4, this goes up by 6, and this goes up by 8. Is this linear? Yes or no? No, because the rate of change is not constant. From here, I go from 5 to 10 to 20 to 40. So here I add 5, here I add 10, here I add 20, next one up I add 40, and so on. That's not linear either because the change in y over change in x is not constant. Questions on that? Now, there's 2 forms that you need to know, and they're referenced on your assessment. Whenever I ask someone what the formula for slope is, you all become like little parrots. And you keep yelling out everything that you know. So tell me something you know about line. Y equals mx plus b. What's the formula for slope? Y equals mx plus b. What's your address? Y equals mx plus b. Over and over, you say this y equals mx plus b. That's in slope-intercept form. The m represents your slope, which is the change in y over the change in x. Or, now, we could say it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1, not x1, y1. It's sub 1, meaning it's a subscript. The other way that you need to see, we'll get to it at the end, I guess. The m is your slope and the b is your y-intercept. So looking at what we've got, here's my y-intercept. It would be the point 0b on the Cartesian plane. Hands up, please, if you heard Cartesian plane before. I found this out from the last class. Who's heard Cartesian plane before? Cartesian plane is the same as saying the xy plane. Okay? And we're going to work on this year. You're going to know probably 10,000 new math words that you didn't know before. So you have a math vocabulary beyond that of a fourth grader. This is called the Cartesian plane when we're graphing it out. It's the same xy plane we had before. Your slope is the m value, and it's the change in y over the change in x. Now, and you use this form. This is the easiest form, or this form as it's given. It's easy to identify the slope and the y-intercept. There's another formula called the point slope formula. Now, if you know the slope and the y-intercept, you use this. If you know a point on the graph and the slope, you use the point slope form, which is y minus y sub 1 is equal to m times x minus, times is equal to m times the quantity x minus x sub 1. You don't need to know the y-intercept. x1 and y1 are points on the graph. Let's see. Understand that when you list this out, so here's our formula. When we list this out, you're going to be making replacements. You're going to be making replacements here, here, and here. Now, the other thing that you need to know, and they do a terrible job of explaining this to you before, slope isn't equal to rise over run. This I don't want to see. Think of it like this, because that's so vague. If I tell a kid to go run, everyone's going to pick, or most people are going to pick different directions. Let's give it some specifics. Your slope is really rise over right. To give the points, or sorry, to get the slope given 2 points on a graph, pick the lower one, count out how much you rise and how much you move to the right. And that ratio, or that fraction, is going to be your slope. Questions on this? Looking at what's there, all of these represent the exact same line that's shown in there. By the way, automatically, I'm looking at this now and I'm irritated because I didn't even see that this wasn't done previously. Who can see something on it that they want to change right now, that they're disgusted by? Outraged from Geo on our Cartesian plane? No one? Thank you. Look, you should be so angry right now. Please don't be angry at me. These should have arrows at the end and arrows at the end of the axes. Notice, by the way, when I do this out, please make sure you always fill up the graph in its entirety, not some of it. If I give you the space, fill the full graph. Looking at this, if I'm giving the equation out in y equals mx plus b form, which is going to be slope-intercept form, the first thing I need to know is my slope. Here's how we do rise over right. Pick one point, pick another point. Take the lower one, count the rise over the right. So my rise is going to be 1 unit. My right is not 2 units because I didn't move to the right. It's -2 because I moved to the left. So my slope would be 1 over -2, which is -1/2. So when I do that, now I need my y-intercept. I count, because I'm a big kid. I can go through and count and say my y-intercept is 5. Now all of these subsequent points that are here, all of those points that are listed out, you can go through and plug in and give out these equations. They mean the exact same thing. The first one up, y minus 6 is equal to negative 1/2 x, the quantity x plus 2. I look at this and say, all right, well, that's my slope, and it goes through the point negative 2, 6, because remember, it's minus y1. Why is this going to be a plus 2 here? Hands up, please, if you can tell me why there'd be a plus 2 next to the x. What do you want to say? 2 negatives make it positive. Negating a negative makes the value positive. Questions on that? Let's bounce over. Now, here's one way to remember this, because you all tend to be very poor at this. And the way that I do this is so terrific. Once you see it this way, if you struggled before, you won't anymore. This line right here, we can go through and list out the equation of it. Now, you all in general, most kids struggle whether that's an x equals line or a y equals line if it's going side to side. Raise your hand right now if you remember from Geo whether that's an x equals or y. We got 2, 3 of 4, maybe more. What do you want to say? There you go. The way to remember it is this. If you don't, when you think of a y equals line, that's what it looks like. When you think of an x equals line, think about what the letter x looks like. Which one is the one that goes side to side? The y is. Which is the one that goes up and down? The x. The letter tells you what the graph will look like. Now, if I graph out a horizontal line, think about the point that this could go through on the Cartesian plane. Let's say it goes through the point negative 5, 2. Let's say it goes through the point 1, 2. And let's say maybe 7, 2. All of those points share the same y value. So it would be y equals the number. Does anyone remember what the slope of a flat line is going to be? Think about your rise over right. 0. Yeah, your rise is always 0. One thing also that you all tend to make, well, maybe do better than most. You can get a 0 in the numerator. You can't get a 0 in the denominator. So this is okay. This means no. You're not going to get an output value. Over here, a vertical line is one that goes straight up and down. It's going to be x equals. So if I were to give out points on this line, I'd say this is like 1, negative 3. This would be above it, so it would be 1, let's say 2. And over here, maybe 1, 8. And the slope on that line, your rise you can get, the right you can't. Questions on that? All right, hands up please if you can tell me what we know about parallel lines. There you go. And they actually have something else. I'd say that might be an okay definition, but I want to say something else. One more thing you have to have. They do have the same slope. Who can tell me, add to that definition? Because there's one little bit you have to throw on it, otherwise something falls apart. Yeah, but that's a property of the same slopes. I guess they have the same slope, but they have different y-intercepts. Because if they have the same slope and the same y-intercept, they're the same line, yeah. So let's make sure that we understand there is a little bit of a distinction. I'm not trying to be a wordsmith on it. This first line here, this is the line y equals 2x minus 5, so is that would be our blue line, where I'm giving you that equation. Now you all are going to generate for me the equation of the line in red. Looking at that, to figure out what this equation is, the first thing I need to do is figure out, because it's in the form, remember it's going to be y minus y1 is equal to m times the quantity x minus x1. Now looking at what's there, which part of this equation can we fill in that currently is not filled in? Hands up please if you can tell me that. What part of this equation can I fill in that currently is not filled in? And it's the easiest part. What do you want to say, please? The slope is going to be, careful, just 2, yeah. Some of you, when you give the slope, you don't associate the variable with it. but our slope is going to be 2. Now, I can't just pick any point based on what's given, because I'm given half of an ordered pair. So the point that this graph has to go through, or in order to generate this specific equation, which half of the ordered pair that that line goes through do I know? Hands up, please, if you can tell me that. Think about the x comma y. Which half of the ordered pair do I know based off of the equation that's given? What's given? Which part do you know? What's next to the y? That's y minus 3. Where did that minus 3 come from? Well, you know it's got to go through the point something comma 3. That's where this goes. That's where that came from. Now, go to the graph and go to where the y value is 3. Hands up, please, if you can tell me what the x value is when the y value is 3. We got 1, 2 of us, 3. What do you want to say? So can you please finish out this equation? What would you have after you did this part out? Keep going. What would you have? What do we know about perpendicular lines? Hands up, please, if you can answer that. One person. I'll go over and get Dr. Welker right now, and we'll come over and yell.
The slopes are opposite.
There you go. So you negate, transpose the numerator and denominator. The lazy definition that we're not going to accept if reciprocal is flip. So one of these lines is y equals 5/3 x. So the first thing I'm going to do, 5/3, 5/3. Next one up, you've got y is equal to. Now we need to get the equation of this line here. So as I do this out, this is going to be y equals, we'll give it in y equals mx plus b form. Hands up, please, if you can tell me the m part of the y equals mx plus b form. We got one person. Outstanding. 2 of you. Two of us. 3. For negative 3/5 x, you can tell me what the rest of this line is going to be. Look at that specific line. What do we need to tack onto this that currently isn't associated on it? Questions on that? All right, hopefully we can rip through this next grouping pretty quick. Go through right now, please. You're going to answer A, B, and C. All right, let's start off with this. Grace P, what is the answer to 1A?
Equals -3
Close.
plus 3.5.
Next one up. Sean, what would you go through and what did you get for your answer for B? Oh, Sean K. There's two of you? Oh, sorry, Sean K.
Well, I don't know.
Which, you get to pick. Now, which one do you think you want to use? Which one would make your life a lot easier?
Well, the y minus y.
So use that.
So you just go on the slope
Mhm.
by 1/2, so y minus y.
Careful. Equals, you're right with the 1/2 going there. We've got a piece here and here to fill in. What goes in those spots? What's your x1, y1? Sean, this would be our x1, this would be our y1. So it's y minus y1, so what would you fill in? Yeah, put that here.
You chose to put it on the board. Just put it on the
Okay, I
paper.
did.
Oh, it's not,
It's
yeah.
not on our paper.
Yeah, you gotta fill it in.
Yeah.
Sorry if there was confusion. I do that because sometimes, especially with enriched kids, literally, there's been years where I've handed people a packet and then a kid would come in the next day with everything done. Is that the point?
Yeah, you just put it in.
Okay, so what would you have?
I plus w equals 1/2 x minus 1.
Now, why is that a plus 7 then? You can tell me why that would be a plus 7. Yeah. Two negatives make the positive. Now the next one, if it's perpendicular, there's actually two answers for this. Marissa D. Where's Marissa D? Which one did you want to use? So what would you give if you're giving out an answer? It's got to be perpendicular to that line passing through that point. Now, that's the right slope, and you recognized right away that the point 0, 2 is your, who did it the other way? What do you want to say you gave?
Y minus 2 equals -1 more x minus 0.
Quantity x equals 0, this goes to 0, you can bring the two over. You're going to get the same thing. They're equivalent to each other. Pick the notation that's easier for you. Which one is the situation calling for? If you're really a math thinker, you'll recognize where is 0, 2 on the Cartesian plane. Well, I go over 0, up 2. That's still on the y-axis, so I'm good right away. Now, for the next one, those are the missing things. Go through, please, and fill in. And complete questions A, B, and C. Go through right now, please, and complete out A, B, and C. Take a look at what's there, and where's Riley P? Riley, what would you do to give out A? What would your first step be? Because what are you trying to find from this? The equation of what? Yeah, you're trying to get out the slope. So when you do that, what did you get for your slope value?
That way.
Nope. Careful, it's not just 4. 4/5. Remember, you got to divide both sides by 5 when you're done. Solve this out for y, and this becomes a slope of 4/5. Now it's parallel, which means that the slope is the same. Thomas H., what would you do next from here? Which equation, by the way, do you want to use? Do you want to use the point slope form or slope intercept form? Okay, so what would you write out? Have a point slope looks like this.
Y minus 3 equals 4/5 x plus 2.
I'm gonna, as you said it to me, it's this. What do you need to tack on that you didn't say? Remember? Because is this the same as this? No. And again, I'll be a stickler now. You can hate me all you want. You will love me the day you get a 98 on that exam and you look at all your friends and they're going, I got a 71. I got a 53. I had a 96 during the 4 quarters. I see that and my brain starts to hurt. A mild aneurysm. By the way, some of you, be prepared, especially you all in the front. If I go down, right, if I have a heart attack right there, or a stroke from one of your answers, just pose me good until the EMTs arrive, okay? I don't want it to be like awkward. Now, and don't leave the room. And just remember to be nice to the next teacher that you have after from your bad answers when you tell me. Let's look at the next one. Is this lead line is perpendicular to the x-axis passing through the point? Before we start freaking out going, oh my God, I don't know what to do here. If you're stuck, the first thing that you should do is draw it out. Formulas are actually a secondary understanding. The first one's a visual one, so I'm going to sketch out my Cartesian plane. The point 1, -4. Hands up, please, and tell me which quadrant the point 1, -4 is in. Did we do quadrant numbers, Sean? What do you want to say? 4. I'm going to go over 1, down 4. That's here. So there's a point now. It's perpendicular to the x-axis. That means it's going up and down here. Hands up, please, if you can tell me what that equation is going to be. No. The slope is undefined. Yes. What's the equation of that line? Who remembers what that equation is? We don't remember the equation of the line? Guessing for the equation of the line. 2 of us? What? Everywhere along the line, x is equal to 1. How about for C? Amalia, what do you say for C? What's missing that we need to have that we don't currently have? We don't pass us through those 2 points. What don't we have that we need? Perfect. Do you know how to find the slope? Do you remember?
Y2 minus Y1
So now I'm going to make my replacement in, and Tommy, what would you go through and have in the numerator? What would you write out now? What's your y2 value? Which one are you picking? Okay, so 3, then what? Okay. All over, what would you have down in the denominator? You need to go into the calculator, fine. Emily H., what would you go through and get as the final fraction value? Nope, careful. 5 minus -2. Up. 3 minus -2. What's that going to give you? Minus and negative is the same as plus.
Oh.
When we do out our slope now, understand you never leave a negative in the denominator. So, Nick B., which point do you want to use to give out the equation of the line?
I use -2 or 5 negative 2.
Okay, so what would your equation look like if you used a 0.5 negative 2?
Y plus 2 equals negative 5, 6 times 5 if x minus 5.
Terrific. Terrific. Questions on that? Let's bounce forward, please. Read out and answer question 3. There's actually some extraneous information we were asking about it in the other sections. Read what's there. You all can, you're more than capable of answering this out. Looking at what we've got, Sean L., what would you say the x represents in this function?
It represents the number of things.
You know? Anthony, what do you think it represents? No? Royce?
The cost of each path.
No? We're getting there. Yeah, it's the number of hats that they're selling. That's what varies. Now, the next part, what would the 50 indicate in there? Hands up, please, if you can tell me what the 50 is. Yeah.
How much is funds coming from? Like total?
You're not wrong. I put it in well, I guess I put it under a bigger umbrella. You gave me a situational answer, which applies to this. So we could say, what did you say it was again?
How much is funds coming from?
So let's say I'm going to put it under this umbrella. Initial cost. There's another one it can be referred to as your fixed cost. There's another one that we go through and say that it actually could be for this case. Does anybody want to think about it in real world context? What could that 50 represent if that's the profit function? You have to subtract 50 from what you have. Yeah, I think that would fall under this category. This one's sort of more specific. They said this, and I didn't even think of it this way. There might be an entry fee to be there. You have to pay rent if you have a business, if it's not out of your house. The next one up, how many caps must they sell to make a profit? Now, let's do this. This is a life skill, and hopefully this is a good equation for you. Sorry, I said equation, it's an inequality. Now, if I'm looking to make a profit, think about that for just a second, and give yourself, you own the business, the money is coming in. In order for me to make a profit, does my profit amount need to be greater than or less than 0? Think about that for a second. To make money, profit, does my profit need to be greater than 0 or less than 0? You can tell me which one you want to go through. And do that 3 people, seriously? This would be one of those questions that I have a heart attack on. Yes. Thank you. Holy cow. So, in general, it's always a good idea if you have a business for the profit function to be greater than 0. So we need to figure out how many hats they have to sell in order to make it. So I'd say 7x minus 50 needs to be bigger than 0, because remember, P of x is our profit function. We go through, bring the 50 over, divide by 7. Now this is the part where it starts hurting my head. Allegedly, you all are honor students. Allegedly. And I say that because in the other class, we got into a legitimate argument where they're going, how many hats? Now, what's the answer to this question? 8. Can you sell 57ths of a hat? No. We were talking about, there's one question that came up on the Regents exam, and there were adults arguing this against smart people like myself, and the answer key, and they're going, the question was like, the number of deer in a field is modeled by, you know, this equation. You plug the number in after a certain number of years, whatever it is. The answer came out to be like 12.75. Or sorry, it was 12.2 deer. What would the answer then be? 12, because you haven't crossed the threshold of 13 and it doesn't round up. And there's people going, well, we should take 12.2 as an answer. Now, raise your hand, please, if in here you've seen, over the course, how old are you all? In the 14 or 15 years you have been on the earth, if you've seen 12 deer, at least. Not together, individually. Who's seen 12 or more deer? Terrific. Who here has seen a 0.2 of a deer running freely in the field? It doesn't happen. There's people arguing. Put it in context. Can you make a profit at 7? No. Can you make it 1 at 8? Yes. 7 is just losing money. 8 is making a profit. Here's another one. Someone started arguing, going, well, what does this mean? Because I had teachers before that told me to highlight and underline, blah, blah, blah. It's terrific. Well, you got to put it in context of the question. Do you need that $5? Does it relate to anything that we're doing? No. This part here, it doesn't. If I asked you what her production cost was, then you would need that. All right. So we didn't get to 3 of the questions that we need to go through and get to. So what I'll end up doing tonight, I'll say this. You have 2 things for homework tonight. 2. Number 1, you go through and do those questions on separate paper. Do you do them in the homework packet? Yeah. You're going to have the answers ready for you next time you come in. We don't go over answers, though, in here. I'll show them to you. You can see them. You're going to be handing it in. If you have a question on it, put a star next to it on your paper. You can come and see myself or Ms. Coy. The other thing, go to the class YouTube page. And we just finished our first day. I think this is on linear functions. Scrub. You don't need to watch the full video. Scrub to the end so we can see how to do questions 4, 5, and 6. Okay? It takes maybe 5 minutes. The bonus is you get to hear even more of me. All right? And I'll post a link through the Google Classroom, and I'll send it out through Remind as well. Yes? Take a look at what you need for homework.
Yeah.
It says day 1. See, no, right here. It says day 1. And then the numbers go to you, so it's comfortable. Okay? Have a wonderful rest of your day. Go change the world.
I want to keep it all together, and I can't.